Pseudoscience is a claim, belief or practice presented as scientific, but which does not adhere to the scientific method. A field, practice, or body of knowledge can reasonably be called pseudoscientific when it is presented as consistent with the norms of scientific research, but it demonstrably fails to meet these norms. Pseudoscience is often characterized by the following: contradictory, exaggerated or unprovable claims, over-reliance on confirmation rather than rigorous attempts at refutation, lack of openness to evaluation by other experts in the field, and absence of systematic practices when rationally developing theories. The term pseudoscience is often considered pejorative because it suggests something is being inaccurately or even deceptively portrayed as science. Accordingly, those labeled as practicing or advocating pseudoscience often dispute the characterization. Science is distinguishable from revelation, theology, or spirituality in that it offers insight into the physical world obtained by empirical research and testing. Commonly held beliefs in popular science may not meet the criteria of science. Pop science may blur the divide between science and pseudoscience among the general public, and may also involve science fiction. Pseudoscientific beliefs are widespread, even among state school science teachers and newspaper reporters. The demarcation between science and pseudoscience has philosophical and scientific implications. Differentiating science from pseudoscience has practical implications in the case of healthcare, expert testimony, environmental policies, and science education. Distinguishing scientific facts and theories from pseudoscientific beliefs such as those found in astrology, alchemy, medical quackery, occult beliefs, and creation science combined with scientific concepts, is part of science education and scientific literacy. Etymology. The word pseudoscience is derived from the Greek root pseudo meaning false and the English word science. Although the term has been in use since at least the late 18th century, the concept of pseudoscience as distinct from real or proper science appears to have emerged in the mid-19th century. Among the first recorded uses of the word pseudoscience was in 1844 in the Northern Journal of Medicine, I 387. That opposite kind of innovation which pronounces what has been recognized as a branch of science to have been a pseudoscience, composed merely of so-called facts, connected together by misapprehensions under the disguise of principles. An earlier recorded use of the term was in 1843 by the French physiologist François Magendie. During the 20th century, the word was used as a pejorative to describe explanations of phenomena which were claimed to be scientific, but which were not in fact supported by reliable experimental evidence. From time to time, though, the usage of the word occurred in a more formal, technical manner around a perceived threat to individual and institutional security in a social and cultural setting. Overview. Scientific methodology. While the standards for determining whether a body of knowledge, methodology, or practice is scientific can vary from field to field, a number of basic principles are widely agreed upon by scientists. The basic notion is that all experimental results should be reproducible, and able to be verified by other individuals. These principles aim to ensure experiments can be measurably reproduced under the same conditions, allowing further investigation to determine whether a hypothesis or theory related to given phenomena is both valid and reliable. Standards require the scientific method to be applied throughout, and bias will be controlled for or eliminated through randomization, fair sampling procedures, blinding of studies, and other methods. All gathered data, including the experimental or environmental conditions, are expected to be documented for scrutiny and made available for peer review, allowing further experiments or studies to be conducted to confirm or falsify results. Statistical quantification of significance, confidence, and error are also important tools for the scientific method. Falsifiability. In the mid-20th century, Karl Popper put forth the criterion of falsifiability to distinguish science from non-science. Falsifiability means a result can be disproved. For example, a statement such as, God exists, may be true or false, but no tests can be devised that could prove it either way. It simply lies outside the reach of science. Popper used astrology and psychoanalysis as examples of pseudoscience and Einstein's theory of relativity as an example of science. He subdivided non-science into philosophical, mathematical, mythological, religious and metaphysical formulations on one hand, and pseudoscientific formulations on the other, though he did not provide clear criteria for the differences. Another example which shows the distinct need for a claim to be falsifiable was put forth in Carl Sagan's The Demon-Haunted World when he talks about an invisible dragon that he has in his garage. The point is made that there is no physical test to refute the claim of the presence of this dragon. No matter what test you think you can come up with, there is then a reason why this does not apply to the invisible dragon. So one can never prove that the initial claim is wrong. Sagan concludes, now, what's the difference between an invisible, incorporeal, floating dragon who spits heatless fire and no dragon at all? He states that, your inability to invalidate my hypothesis is not at all the same thing as proving it true. Once again explaining that even if such a claim were true, it would lie outside the realm of scientific inquiry. Merton's norms in 1942, Robert K. Merton identified a set of 5 norms which he characterized as what makes a real science. If any of the norms were violated, Merton considered the enterprise to be non-science. These are not broadly accepted in the scientific community. His norms were originality. The tests and research done must present something new to the scientific community. Detachment. The scientists' reasons for practicing this science must be simply for the expansion of their knowledge. The scientists should not have personal reasons to expect certain results. Universality. No person should be able to more easily obtain the information of a test than another person. Skepticism. Scientific facts must not be based on faith. One should always question every case and argument and constantly check for errors or invalid claims. Public accessibility. Any scientific knowledge one obtains should be made available to everyone. The results of any research should be openly published and shared with the scientific community. Refusal to acknowledge problems. In 1978, Paul Thagard proposed that pseudoscience is primarily distinguishable from science when it is less progressive than alternative theories over a long period of time, and its proponents fail to acknowledge or address problems with the theory. In 1983, Mario Bunge has suggested the categories of belief fields and research fields to help distinguish between pseudoscience and science, where the former is primarily personal and subjective and the latter involves a certain systematic approach. Criticism of the term. Philosophers of science such as Paul Feyerabend argued that a distinction between science and non-science is neither possible nor desirable. Among the issues which can make the distinction difficult is variable rates of evolution among the theories and methodologies of science in response to new data. In addition, specific standards applicable to one field of science may not be applicable in other fields. Larry Lorden has suggested pseudoscience has no scientific meaning and is mostly used to describe our emotions. If we would stand up and be counted on the side of reason, we ought to drop terms like pseudoscience and unscientific from our vocabulary. They are just hollow phrases which do only emotive work for us. Likewise, Richard McNally states, the term pseudoscience has become little more than an inflammatory buzzword for quickly dismissing one's opponents in media sound bites, and, when therapeutic entrepreneurs make claims on behalf of their interventions, we should not waste our time trying to determine whether their interventions qualify as pseudoscientific. Rather, we should ask them, how do you know that your intervention works? What is your evidence? History. The history of pseudoscience is the study of pseudoscientific theories over time. A pseudoscience is a set of ideas that presents itself as science, while it does not meet the criteria to properly be called such. Distinguishing between proper science and pseudoscience is sometimes difficult. One proposal for demarcation between the two is the falsification criterion, most notably attributed to the philosopher Karl Popper. In the history of science and history of pseudoscience, it can be especially hard to separate the two, because some sciences developed from pseudosciences. An example of this is the science chemistry, which traces its origins to pseudoscientific alchemy. The vast diversity in pseudosciences further complicates the history of science. Some modern pseudosciences, such as astrology and acupuncture, originated before the scientific era. Others developed as part of an ideology, such as Lysenkoism, or as a response to perceived threats to an ideology. Despite failing to meet proper scientific standards, many pseudosciences survive. This is usually due to a persistent core of devotees who refuse to accept scientific criticism of their beliefs, or due to popular misconceptions. Sheer popularity is also a factor, as is attested by astrology, which remains popular despite being rejected by a large majority of scientists.